Today we're going to be going over scientific notation. And scientific notation is used a lot in almost every single chemistry problem. It's basically a way to show a particular number or value in an easier format to look at. So for example, I have this number right here, this 4,440,000 number. So say this was an answer to some problem or just a number that you had to communicate to another scientist. That is a pretty big number, but a way you can convert it to scientific notation will be equal to 4.44 times 10 to the 6th. And I know what you're thinking. You're like, where did this come from? What is this? How is there a 6 in there? I don't see a 6 in that number. But in this video, we're going to go over how we came to this and how it works out. So over here to the right, I have the general format of scientific notation. Big N times 10 raised to the little n. So let's talk about what all these mean. So the big N can equal any number between 1 to 10. Okay, so if we look at our example, the big N right here is 4.44. That is between 1 and 10. Okay, so we're good so far. Now, if we look at this right here, 10 times 10 raised to the little n. The little n can be any integer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or negative 1, negative 2, negative 3, and so on. So that is the general format for scientific notation. But let's talk about what this times 10 to the n or whatever number, let's talk about what it means. So right here, I went ahead and wrote everything out so you didn't have to sit here and watch me write it. But for example, let's say we have 10 raised to the 1. Okay, so we could pretend that that's going to be the number right there. What would that do? So 10 raised to the 1 equals 10. So you're basically going to do n times 10 to the 1, or just times 10. So it would make the number bigger. And then 10, say it was 10 raised to the 2, that means 100. So that multiplied times 100 would make it even bigger. 10 raised to the 3, 1,000. 10 raised to the 4, 10,000. 10 raised to the 5th, 100,000. And then finally 10 raised to the 6th, 1,000,000, which is exactly what we have here. So this number right here, if we convert it to scientific notation, which we did, we have 4.44 times 10 to the 6th. Now, the 4.44, that's a very small number compared to what we have before. But when you multiply it times the rest of the scientific notation, 10 raised to the 6th, that's equivalent down here, that's equivalent to 1,000,000. So this number times 1,000,000 will equal this number right here. So that's exactly what scientific notation is doing. It's just making it simpler. Like, instead of looking at all of this, you're just looking at this right here. And then this times 10 to the 6 lets you know that, hey, this is a lot bigger number than what you think it is. So if we go on the other hand, instead of 10 raised to the 1, say we had 10 raised to the negative 1. So same thing as over here, but this time we're doing negatives. So 10 raised to the negative 1 will be 0.1, negative 2, 0.01, then 0.003, then 0.000, or not 0.003, but 0.001, and then 0.0001, and then 0.00001, and so on. So basically, the differences between a positive integer and a negative integer. If you have a positive integer, such as this case, the number is really bigger. But if you have a negative integer, look at this. Say, pretend we have, let me do an example real quick. Pretend we have 4.44, just so we can have a good comparison, times 10 raised to the negative 6. So same exact numbers. I know that looks ugly, but bear with me. It's hard to write on this. So we have the same exact numbers, 4.44, 4.44. But the only difference is this is multiplied times 10 to the 6. This is multiplied times 10 to the negative 6. So in 10 to the 6, we already discussed that it's going to be 4.44 times 1,000,000, which is going to make it a way bigger number. In this case, 4.44 times 10 to the negative 6. The negative 6 is basically equivalent to 0.000001. So 4.44 times 10 to the negative 6. That's going to equal 4. That is going to equal, well, almost didn't have enough room. So that number is a lot smaller than a million. So that's basically showing like what is the differences between this positive and a negative, like what can it do. So next we're going to go over converting the numbers to scientific notation. Alright, so converting numbers to scientific notation. So let me write this out. So here's the method that I use in order to convert a number or certain value into scientific notation form. So I'm going to make up just a random number. Let's see. Let's do, I like the number 4. 8, 5, 0, 0, 0, 0, 0, 0, 0. Oh, that looks like a 6. Hold on. Oh, I messed that one up too. Alright. That many zeros. So we're going to convert that to scientific notation. So here's what we do. So I'm going to put an equal sign. And I'm going to change colors to make it look nice. Now in scientific notation, and actually, before I do that, the general format, I'm going to write right here. Remember, n times 10 raised to the n. Okay, so back to what I was doing. Now remember, in the general format, this n is a number between 1 and 10. So therefore, basically, the very first number that we're going to have has to be 4 point, and then, because there's a 4 right here, 4.85. So then I'm going to put 85. 4.85. That's the easiest part. All I did was rewrite this and move the decimal so that there's a single number to the left of the decimal. Pretty simple. Now the next part, the hardest part of this, is the times 10 to the what number. And this is what all you have to do. So let me change colors again. We'll do orange. So here's the tricky part. Let's look at this big number right here again. Here's the decimal right here, right? Or sorry, right here. I didn't draw before, but that is where the decimal is. But now we have to move the decimal from here to right here between the 4 and the 8. So all we have to do is count how many places we have to move. Alright, so you ready for this? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we moved 9 places. So therefore, we know that this is going to be times 10 to the 9. Now you're thinking, is it going to be positive or negative? So there's 2 ways you can think about this. One way, if you want to like memorizing, is we're converting the values to scientific notation. And since we move the decimal to the left, it's going to be positive. That's going from values to scientific notation. So that's a way you can memorize that it's going to be positive. Another way is you can think, this number that we started off with, that's a big number. That's bigger than 4.85. So therefore, it's going to have to be multiplied times 10 to the positive number. Because if it was negative, if we did 4.85 times 10 to the negative 9, then this would equal 0.0000000, so many zeros, 485. So remember that negative number will make this value smaller. But this number is way bigger, so we know this is going to be positive. Okay? So we'll do another quick example. Actually, let's okay, so say we have 0.000000009.4, got to throw a 4 in there, 3. Okay? Convert that to scientific notation. So the first thing you got to think, what is the very first number that I see other than 0? And going across 0, 0, 0, 0, 0, 0, 0, it's a 9. Okay, so 9, that single number, that we put to the left of the decimal is going to be a 9. So 9 point, and then what comes after is 43. Alright, so that's the easy part. That's good to go. Now, for the fun part, where's the decimal at in here? Where is it? Okay, I drew it here for you this time. There it is right there. So all we got to do is move the decimal to between the 9 and the 4. So all we have to do is count. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 again. That's a coincidence. I didn't mean to do that. I'm sorry. So 9. But is it positive or negative this time? So before we moved to the left, so that was positive. This time we're moving to the right, so we know it's going to be negative if you like memorizing, or you can just think about it intuitively. So if we look at this resulting number, we have 9.43 compared to what we had before, 0.000000, so many zeros, 943. This number is a lot smaller, so you are definitely going to multiply it times 10 to a negative integer. And there you go. It's that simple. Okay, so now we're going to learn the method on how to convert from scientific notation back to the original expanded value. So say we had a scientific notation of 5.93 times 10 to the 5th, and we wanted to convert it to just the regular format. So the very first thing you would do is you look at basically the end value, which is 5.93, and you would write it. And it's just easy. We'll write it over here without the decimal, because the decimal is going to move. Just like that. So, so far we've used the information from the uppercase N. Now, where the decimal goes is going to be dictated by this number right here, the 5. So, so originally the decimal is right there. Originally. Now, we can only move the decimal over to the left or to the right. We can't move it up and down, just left or right. And you should understand that if you moved it to the left, it would become 0.593, which is smaller. So moving to the left will make it smaller. Moving it to the right will make it 59.3. So if we moved it over to the right one space, it would be 59.3, making it a bigger number. So moving to the left one space will make it 0.593, so a smaller number than the original. Moving to the right will make it 59.3, a larger number than the original. So if we look at this right here, instead of trying to memorize, you can just look at the times 10 to the 5th. That is going to make this a bigger number. So making it bigger is moving it to the right. So we just got to move it to the right. And how many times? Well, it all depends on what number it is, which is 5. So 5 times. 1, 2, 3, 4, 5. And all these empty spaces, all you got to do is throw some zeros in there. And there you go. So 593,000. Now let's try another one. 7.92 times 10 to the negative 7. Alright, so that's going to equal, and using the same method, then you got to think ahead and leave some space. 792. So originally the decimal is right here. Oops. Right there. Now the exponent over here is negative 7. 10 to the negative 7 will be something like 0.000000. So this is definitely going to be a smaller number. If we were trying to make it a smaller number, we move it to the left 7 times. 1, 2, 3, 4, 5, 6, 7. And all those empty spaces, throw some zeros. 1, 2, 3, 4, 5, 6. Now we moved it over 7 spaces, but only 6 zeros because the very first space was just moving in front of the 7. Oh yeah, I forgot to put the decimal. And there it is. And then, so that's how you convert from scientific notation to back to the values. In the next video, we'll go over multiplying and dividing and adding and subtracting scientific notation values.